Well, hi, good morning. Thanks so much for joining me here in my shop on, it's the Ides of August, August 15th. So, I had been working in my shop here, but not posting videos, just working my way up to be able to do a proper alignment job on this receiver, or at least do some alignment type things, verify a few things. Exceptionally challenging it has been. Working on FM radios is a lot different than working on AM shortwave or broadcast radios. The frequency is just that much higher, and everything is that much more difficult to pull off. So I have a nice piece of equipment here. I have a sweep generator here, but I can't use this on the radio. It doesn't go anywhere near a high enough frequency to be used. But I do have two other older pieces of equipment that I'm not all that familiar with. One I just acquired a couple of months ago, and that's this guy here. Is a straightforward signal generator. Will produce a signal all the way up to 110 megahertz. So I've been checking that guy out, and this complex marker generator or sweep generator with a marker generator built into it. This is really intended for television service work, but right in the middle of the old television reception band, right between channels 6 and channel 7, is the entire FM band and aircraft band too. Oddly enough, right in the middle of the old television bands. So this guy is able to help out with FM alignment, but again, my familiarity with it is low. I've only played around with it. I don't think I've ever actually tried to put it to work until right now. So what I've done this morning, in order to find out about those two pieces of equipment, is I brought in a radio with a digital tuner. You can't read it there, but it says 108. That's the top of the FM band. And then I've just got the antenna from this radio just laying here on the bench to pick up signals from the two signal generators, so I know what they're doing. So let's do it again. We'll start with this guy up here. Let me just change the lighting here a little bit. See if that helps. Let me change it a bit. Okay, well, it's not the best in the world, but it's the output. Turn it up. So it's a high level output. Turn up the volume on the radio, which is, I think it's responding to one of these. I just heard a funny pop in my shop from up in this area. Something popped. No smoke, no flames, no sound. Okay, so I'm going to turn this guy away from the 108 area here, just to make sure that it's not. Maybe this guy's right on 108, so turn up the radio, tune him a bit. So that says, so this is 108 up here, that's about 104 on there, but I'm sure it's actually putting out 108 because the receiver here is tuned to 108. What else comes out of this? That's probably exactly half. That's 50, around 55 there. Bit of dirt in it maybe. Okay, so what we've got is a signal generator put out 108, top of the FM band. I can modulate it if I care to. Internal modulation. What is that? Okay, as horrible as that sounded, there is some kind of internal tone. It sounds like 1,000 hertz. Who's making that noise? Okay, now, so that's a single frequency. We'll reach the whole FM band. Now what about this guy? This guy's got two outputs to begin with. I was fooling with them just before I started the video here. It's a Heath kit TD alignment generator. Okay, once again, I'm going to make sure the other signal generator is out of the picture here. So this guy has an output here, and he has an output here. This one's marked RF. This one's not marked. This part of the device is the marker generator settings, I believe. And over here is the general RF output. Here's a sweep control right here. So it's a sweep generator. Okay, we're on band D. And let me turn down my radio here. The 108 is somewhere up around here. We have the marker. Oh, how do you like that? So this, yeah, from previous fooling around, I left this right on 108. So we'll flip that out of the way. It's like 125 now. Turn down the output. I'm not sure what's going on here with these two outputs. It could be this is RF only, and this is RF with a marker generator. So two signals coming out of here, a sweeper and the marker, I think. Not exactly sure what they're doing, but appears to be the case that this output is here because of this. Okay, so we can assume this is now putting out a signal at 108, kind of a hashy signal, and here's the sweep width. That has the classic sweep sound to it, so we have an attenuator. Not sure what that's up to. Attenuator for over here. This is called horizontal phase. Not really sure what that's about. Probably something to do with the television horizontal circuits. Okay. Interrupt the marker. Put 108. Oh, that's the wrong one. Turn down this one here. Move it right out. So it's now putting out a 108 megahertz marker signal. I think this is controlling the level. Let me bring the sweep back in. Okay, so we're just listening to this on one channel on the radio here. Let me turn the volume down. I'm going to do the same sorts of things now, but we're going to look at the result on the SDR radio I have here. Okay, so 108 is right here at the top of the red. It's marking the top of the FM band here. And you can see there's something sitting there right now. I'm going to vary the, what do we start with? Let's start with the marker. So let me turn it up a little bit. Anybody see anything? See, I saw something wiggle around there. Now I'm going to change the frequency of the marker. Watch on the screen. Oh, you can see what it is. Where'd it go? Oh, it jumped a long way. So jumpy control. Now trying to get this set. A bit of jumping around there. Oh, right on the money. Okay, so that's on 108. What that other thing is that's just below 108, I'm not sure. But we know the one that's dead on 108 is coming from my generator. Coming from the single frequency generator. Now we'll try to no, that's not right. This is coming from the marker generator. Now we'll bring in the sweep here. See what happens. I'm going to change my SDR screen. I'm going to move it so that 108 is roughly in the middle of the screen here. Okay, can I reduce the marker? Well, so I've changed the level control for the marker generator, and it's moving the frequency back and forth a little bit. doesn't really change the level very much. In fact, the level's higher when it's set lower. So exactly what that is, I don't know. It just says marker. It says marker amp as an amplifier. Okay, we're going to leave that. So it's running right around 108. It's like a fine frequency adjustment in the end. Now we'll bring in the second signal, which is the sweep signal. Try anyway. So I'm moving there. It went right by. So this is freakishly difficult to tune this with any kind of precision. So you see the sweep just to the left of the marker generator. Let me turn up the sweep width and we'll see what happens. First, let me turn up the output here. Did it get stronger? Change frequency a little bit. Okay, how about the attenuator here? Change frequency a bit, but didn't really get any stronger or weaker. So, you know, all those attenuating controls are probably operating the RF output, not the marker generator one. So let me just tune now. Increase the sweep width. Sweep appears to have just disappeared. So it could be as you expand the width, the signal gets a little weaker, just because of the way I'm turning it width down, and it reappears right at the bottom. Okay, so what I'm going to do is I'm going to move I'm going to look at the other output on this generator, the one marked RF. Well, isn't that a big difference? Suppose I could read the manual on this thing and figure all this out too, but it's more fun doing it this way. Okay, so there we see the signal. Let me use the attenuator here. Yeah, it definitely gets lower and higher, and then the vernier or the adjustable. You can see the SDR is compensating for the variation in the signal strength by turning its own level control up and down. That's why the general noise level is going up and down. Like that's low signal, high noise, and then when you put high signal, you can see the noise goes down. So the SDR is doing things too. That's the bottom line. Okay, so sweep width is minimal right now. Let's expand it. Whoa! Wow, okay, so now it's sweeping all the way from, well, let me just turn the sweep down a bit so we can see the edges. There's the edges. From around 107 all the way up to 108,750. Now, it should be sweeping only 75 kilohertz, I think. Of course, you know what? This is intended for a television set, and the sweep width on a television set might be 6 megahertz. You might want to use 6 megahertz of sweep. Because that's what's going on with the video signal in the old television sets. So that's probably why the sweep width is gigantic. Now I know kind of what I got here. Is this going to be useful along the way? So the sweep there, what is that sweep? It's bopping up and down and jumping around just because of sort of synchronicity problems with the SDR, my computer, and all that kind of stuff. I think the reality, there's a nice squarish looking thing there, not jumping up and down like that. What can we do with this? Well, this would provide the S curve and the IF response curve at 108, where I have it set now, 108 megahertz. My other signal generator, the one that's really designed for doing FM work, is fixed at 100 megahertz, but it also produces a sweep width control and all these different things. It's a little better. It's definitely a better instrument for this because things are calibrated more on my stereo FM signal simulator WR52A, as opposed to the Heath TV alignment generator with no other. Model TS4A. Okay, let's go back here to the picture. So you may be wondering, why are you even putting this on video? Because I did do a fair bit of effort getting ready to do the alignment on here, and I'm right at the edge of making it work, but not quite there. So I thought today I would, and I've shot video, but I'm not going to post it because it doesn't really go anywhere. Today I just wanted to get through checking the equipment I have so I know what I've got available now. And I can proceed more on and reminding myself of how this equipment operates because I don't use it very often. I think I'm fairly well armed to go at this set. So time for a little break here. On this kind of equipment, I have to leave this stuff running for like an hour and a half to warm completely up and stabilize. So it takes a long time for that to happen. In the meantime, I'm gonna go play with my cats and read up on some procedures here. Okay, so what I've got now is the everything's kind of the same. I'm going to turn this radio right off here so we don't hear it. The output from the signal generators is just here, and this white wire is the FM antenna for this radio, which is on now. And what I want to do is tune this radio to 108 and hear these signal generators on this radio. That's the first step. Second step is, you can see I have the oscilloscope connected here. There are two test points from which I can make tests here. This one's simpler. The scope goes straight onto it. This is the Afc Test Point, they call it. And the result of this is you should see an S-curve. That's the objective here. There's another location where I use this circuit that I made up, connected into the FM receiver board, and from there I can see the IF response curve, which looks supposed to look something like that. Okay, but I have to hook this circuit up, so I'm not going to go after that. I'm going to go after this AFC thing just to get something up on the scope here so I can get some idea if this is working or not. What was that? Funny sound there? Maybe that was my stomach, in fact. I'm not sure what that was. Okay, so what do we got going here? So we got the signal sweeper going. We've got the single frequency one going up here too. We got everything going here. Who's on what frequency? This is way off 108, so it doesn't matter. And this, remember, is two signal generators coming out of this box. One of them is set very close to 108, and the other one is set very close to 108. So maybe we're going to hear this. Okay, so I'm going to turn. This is on FM here. I'm going to turn it up a little bit. I think that is my stomach that's growling here. Not much to hear. I'm going to tune it now. We'll see what happens. Where am I? Around maybe around 102 or something. Going up. Wow! Ooh, that was exciting. Okay, let me turn it down. Okay, a little further. Something good did come up on the scope. Turn it down. Well, I think that might be the S-curve, only it's a lousy S-curve, isn't it? It looks more like a V-curve. So from here I have to convince myself that the equipment is doing the thing necessary to make the right kind of shape come up there. And then if the right kind of shape doesn't come up there, it must be the fault of the radio and its alignment. That's a pretty tall order to know for sure that all these things are working properly. So I determined that the sweep is gigantic on that thing, so I'm going to turn the sweep down here. Maybe something like that. And what is the sweep? What frequency is the sweep? My guess is they're using the 60 cycles in order to, well, it's not a guess. I know they're using the 60 cycles because I'm triggering the sweep on my scope using the same 60 cycles. I have a 60 cycle setting here, of course, for the trigger, the sweep trigger, and that's how you get a stable display on there. So yeah, that's thumbs up so far. That's pretty good. I think what I might want to do is fiddle around with some of these settings on the box up here. Try and keep the scope in view. So this guy's not doing anything right now. Let's just expand the sweep and watch what happens on the scope. Well, that's great. It tightens up the curve there. It looks a little more like an S-curve now. And that's no sweep. Look at the sharp edge here. Wow. Wonder what that's from. Okay, I am going to increase the sweep again. Wow, okay. And I'm going to change the frequency setting up here, and we'll watch. I think it's just going to move back and forth, but this is so sensitive here. Yeah. Strange shapes. I'm really not sure what this. This must be a cutoff of the sweep. Let me expand the sweep. So I think as I expand the sweep size, I have ideas in my head that I won't repeat. Just leave it at that. Looks like we got an S-curve there. Boy, if I knew the adjustments, I would try them right now to see if I could do that. Well, actually, this is a secondary or a few steps into the alignment process when you're looking at this curve. Ahead of this, we're looking at the response of the IF. So I'm gonna set up for that. That means using this little circuit I built here. Power off on the radio. So if I did post some work I did earlier, you would see me go through a fairly long process to verify which is test point 1, which is test point 2, and which is the extra test point not talked about. Huh? Yes, there's a grounding test point that's not mentioned in here, and the test point number, this is test point 1 we're hooking up to. Test point number 2 does not exist as a test point. There's nothing there to find. Yeah, that's why it took me some time. Okay, we'll put that on the ground. So this little interface circuit, I'll look up here. This is actually supposed to, it's a small detector circuit. And so we should see, well, we'll see what we're going to see. Leaving everything else alone, hit the switch. So I'm expecting, shoot, printed out some stuff, but I never brought it in the shop. I'm expecting a single line trace that looks like that. Oh. Well, I got distracted away there for a little while. That's okay though. The longer the equipment runs in here, the more stable it becomes. So what did we get on the oscilloscope then? We've got, instead of getting a single trace, sort of a DC line, what we've got there is the full signal thing happening. It's not quite what's supposed to come out of this circuit. Let's see what we can do with it. Get just a little bit closer here. First of all, tuning, what do we want to tune? Let's change the sweep width and see what it does up there. Similar to what we saw before. Longer sweep width results in a smaller display, which I can't quite explain. You know, this is triggered at a certain speed. It's running at a certain speed, and it's just triggering every 60 cycles, same as the generator is synced to. Now there's you wouldn't know this because I didn't post the video, but in the FM tuner, the last part of the FM tuner is a transformer that sends the signal on its way to the IF, and that adjustment is the first thing that gets adjusted on the when you're doing an RF alignment. I'm going to go ahead and do that. The problem is only one slug is free, and I'm using this tool to do it with this very slender plastic shaft here. This is the end part here is just a little wider, a little tricky to see. This is the business end that's going to turn the slug. And the idea is, in these transformers, there's basically two coils of wire with a carbon slug inside each one, and the carbon slug has a hole in it, shaped, in this hexagonal shape. And the thing is, you have the two slugs inside these coils. My hands are the slugs, and you adjust them up and down in the coils to change the resonance of the individual coils. One of the instructions is to adjust them away from each other. Exactly what that means, I think I know. So the deal with this tool is you slide it down into the first one, and then you can adjust it, but you can slide it all the way through the first one into the second one, which is down here, and then you can adjust the second one. Well, of course, the scale here, my hand is gigantic, but you can pull up and adjust the top one and pull out, you're done. The problem with this is the bottom one won't adjust. With this thin piece here, and with this locked in the stuck slug, all that happens is you twist this. It builds up strain in here and tension, and at some point, if the slug does turn, it'll snap, half a turn or something. It's very difficult to do any kind of precision with this situation. That's what we're in. But let me turn the slug that can be turned and see what it does. Okay, I'm going to actually show you where I'm going here in the radio. Try anyway. Good. So here's the tuner box. This is the FM tuner box here. And there's a lot of very sensitive components in there dealing with the high frequency, the 100 megahertz or whatever's coming in here. Unlike an AM radio with such a low frequency, this one really matters here. So I'm going to slide the tool in. Okay. Now the tool is engaged with the upper slug at this point. So we're looking at the scope now. Looking at the scope. Looking at the scope. And turning it. What does the scope do? Yes, there is a change. See the change in the shape. You hear the sound change also. So what we want here, and I'm not sure this is being done properly, okay, so I'm still at the early stages of doing this, so things can be happening here that actually aren't correct, and not to worry too much about it right now. We're trying to get a shape here, a very particular shape here, and we may have it here. See, the top is flattened off. That may not be a bad thing here, and it's fairly symmetrical. So for now, I think that's about the best we can do. The diagram in the manual does not show a flat top here, but you know what it could be? It could be signal strength. Let me try and turn down the output. No, it's still flat here. Can I get it up any higher? No, only go down. One of the challenges here is I could be driving far too high of a signal into the antennas here without knowing it, and causing effects that will show up on the scope that are not supposed to be there. These are all things to wonder about now. To wonder about. So that was the sweep width. Now, what if we bring in the marker? And How's that even going to help? I'm going to do it. Well, you know what? I can't really do it, I don't think. Because well, there's something happening there. Oh, there we are. So with the second frequency now coming into the radio, and the frequency is it's 108. It's what the radio's tuned to, 108. That's what's happened. I don't know. I don't see how that's going to help anything at all. But again, just experimenting here, just getting comfortable, even just goofing around a little bit to get more and more comfortable with it. I think the little circuit I built is failing to operate properly, because I really think there should just be a single line here. The input's set on DC. Oh, you can barely see it. There we go. Let me try. I'm gonna move the so I have the ground for the scope here on the chassis. I should really move it to the same ground point as the black cable there. So I'm gonna do that. I'm gonna take this off here first. That changed things. That changed things kind of dramatically. We're seeing a large DC offset now we weren't seeing before. Well, that looks a lot more like an S-curve. It's not supposed to be an S-curve. It's a schmozzle curve, that's what that is. Let me put it on AC here. That's quite an ugly looking thing. Now, let's fool around again with the sweep width. Let me turn the sound up just a wee bit on the radio here. Okay. Now remember, the sweep width is gigantic on this, so I'm turning it up just a little wee bit. My thinking is, well, maybe with just a wee bit of sweep we'll get the right thing, as opposed to a huge range. Okay, enough of that. Try tuning the radio is actually a better way to see what happens here. Tuning the radio. Straight across. That's one side, that's the other side. And in the middle, so it's not quite clear to me. I can actually tune the radio back and forth a bit and this doesn't move when it's in this position. It just isn't, I don't think this is at all what we're supposed to see here. We are supposed to see a nice curve like that, not this schmozzle. Change the scope lead to yeah, it's just not enough left. That's times 10 now. It's just not enough signal to really show up. Times 1 doesn't seem to affect the radio operation. Well, I'm still not in a position to go ahead here with alignment, because I'm still not getting exactly the kinds of things what we need to see. So what's not on video is me doing all this same stuff using this signal generator at 100 megahertz. Essentially didn't really get any better result then or now. So time to stop, think, and go enjoy the day. It's another lovely day outside again. There's only so many of those left, and I think probably a little bit of thinking and a little more fooling around, and I'll get this to work the way it's intended to work, so we can do the alignment process properly. You can't fool around with an FM radio and hope to get somewhere. Fool around with an AM radio, an FM one, it's a little bit suicidal to just fool around. So it's very important to get all this stuff working the way it's supposed to work. Hey, thanks a lot for watching. See you tomorrow.